So you see, I am just trying to excite you about the world of material science. We first gave you an example of a robot geologist. Now I am sharing this table with you. You know these things, but you are looking at them from a brand new viewpoint, and that is why hopefully your interest will be much larger now at a higher level of understanding. Why is the study of materials important? So you can read through it, but you see, when I was trying to introduce myself, I told you that I belong to the focus group of applied mechanics and design. I belong to the focus group of materials and manufacturing. So that answer is already here. Why is the study of materials important? You see, don't read through it. You can, as I told you, you can read later on. Just think yourself and then try to listen to me. And then, right, think, listen, react. Everything around you is made of materials. Either they are natural things like animals and trees and forests and rock and sand and water. These are natural things. Or there are things like gold and aluminum and petroleum and so on, which are also natural but not directly available. For gold and aluminum and iron, you have to dig into the earth. You have to do what is called mining, and what you get out of the earth is called an ore, O-R-E, because it is not gold, it is gold mixed with a lot of other things. It is not iron, it is iron mixed with a lot of other things. So you do mining and you take out the ore, and then you have to develop the science of engineering of how to remove all the other materials and get only iron, of how to remove all the other materials and get only gold, right? So that is the engineering part of the materials. It is also manufacturing in a way, that you take all that rock which contains the gold and so on, you crush it into small pieces, then you make very big furnaces, you melt all this material, you do a lot of chemistry study, that what new chemicals should I mix so that the other materials which are not gold should become compounds and so on, which I can separate out, and in the end I am left with pure gold. Similarly with iron, I take a lot of iron ore from my mines, and then I crush the ores and take them to big furnaces and melt them, and then add other materials and chemicals to it, and ultimately I filter it out so that only iron is left. In the case of petroleum, you dig into the earth, you make oil wells or you make gas wells, or you go into the sea and you do offshore drilling and you go down and so on, and then you get the gas or petrol out, right? But these are still natural materials. Then you convert these materials into your products. You cut the wood from the tree, you convert it into a chair. You cut the wood from the tree and convert it into a table. Now you are making products, right? So my question, or what I was trying to tell you, is that if you look around you, some things are natural. I mean, you eat and drink fruits and so on, those are natural. You should learn how to grow apples. You should learn how to grow wheat. But then you should learn how to convert wheat into bread, right? So materials are there, and materials engineering is there. And when you come to for machines and so on, right? First of all, you make iron, you make steel, you make aluminum alloys. That is already a lot of material science and materials engineering. And then you convert them into a bicycle, into a chair, into a table, into a car, right? So everything around you, whether natural or artificial or man-made, is made of some materials. And every product, whether it is your food or your dress or your machines, are made of materials. So how to create the material, how to get the material from the earth, and how to create it into a form where you would like to use it, and then how to convert that material into engineering product or a food product or a dress product, right? So everything around you is materials. So of course the study of materials is very important. Now if I go back to the definition of engineering, See, all of you are engineers. Whether you are mechanical or civil or industrial, I don't know. But you are all engineers. What is engineering? Now again, pause my lecture, think for half a minute, come up with a one sentence definition of what you think is engineering. Right? Stop, pause, think of one sentence. But then you see, engineers solve problems, correct? But mathematicians also solve problems. Business management people also solve problems. So are they engineers? No. Engineers make products. Yes, very correct. But is a tailor who makes your dishdak and so on, is he an engineer? He is making a product. Is a pharmaceutical person who makes medicines, is he an engineer? He makes products. Oh, no, he is not an engineer, right? So you see, it is correct that an engineer solves problems and engineers makes products. But which type of products, right? Machines. If there is an engineer, he makes machines. So if you use two words, design and manufacturing, and a third word of products, what is engineering? It is designing and manufacturing of useful products. Now you can't think of anybody else, it is an engineer, right? So this is it. All your courses for the all 4 years, 5 years that you do are ultimately trying to make you into a person who can design and manufacture a useful product. Or if a useful product has already been designed and manufactured by some other people, then you should become an expert at using that product, at maintaining that product, and using that product to make something else, right? If you are a petroleum engineer, some other people will have designed your rig and this and that, but you should learn how to use those equipment to make a new oil well, to make a new gas well, to lay down all the pipes and so forth, right? So an engineer is there to design and manufacture a useful product. Now every product, now as I said, I mean, you take the simple example of a table. I have taken that example earlier. If you want to make the table from wood cut from a tree, then your calculations of stress and strain and so on will be there, but then the strength of the wood will be different. So how thick should the table be, what should be the height, what should be the length will change. But if I make the same table with hard plastic, then your calculations will change. If I make the same table with light aluminum, your calculations will change. So the choice of materials changes your design and all calculations, and changes the way you will manufacture the product. Therefore, if your knowledge of materials is not very good, then you cannot design a product correctly and you cannot manufacture a product correctly, right? So these two words are highlighted: production, manufacturing, and processing, the method by which you will make it, right? So materials are there, you have to produce using this material some finished good, and you have to use a manufacturing process which is correctly there, right? So therefore an engineer is there to give you a good product for any use. You have to write, he should give you a good pen. You have to write on the board, he should give you a board marker. You have to type, he should give you a phone or a computer or a tablet to type, and so on, right? So an engineer should be able to give you a good product for whatever work you want to do. To get that good product, you will have to design it and you will have to manufacture it. To do both designing and manufacturing, you should select a proper material, right? Now you take a pen. This pen is 200 paisas, 300 paisas, it writes very well. You go to another pen, it is 1 real. You go to another pen, it is 5 reals. It is doing the same job of writing, but now how long does it last? How smoothly does it write? Right? Is it made very beautifully? Is there some gold in the cap? Right? So the product changes even with. So this is what an engineer is. So therefore materials is very important. Let me now go to the next picture. What do you see? Just the picture. It is an aeroplane. What type of an aeroplane? Is it a fighter aeroplane used by the Air Force, or is it a commercial aeroplane for passengers? Oh, I see lots and lots and lots of windows, right? I see lots and lots and lots of windows, so it means lots of seats. No, so aircraft for Air Force would have only 1 or 2 seats. So no, this is a passenger airplane, but it looks very aerodynamic, very modern and so on. So now you can go back to the previous slide and say, what is HSTC, right? This is civil transport. So this is there, but this is HyperX at Mach 7. What is Mach 7? Anybody? All of you know it actually. What is Mach 1? Anybody? The speed of sound is called Mach 1. All your normal aeroplanes, all commercial aeroplanes are below the speed of subsonic. They go at 500, 600, 700, 800 kilometers per hour. The speed of sound is more than that. You know, there was one passenger aircraft which was supersonic, which was later stopped. Do you remember the name? Yes, those of you who remember it correctly, it was Concorde. But because it made a lot of sound while landing and taking off, so it was discontinued. Now they are trying to make more supersonic passenger aircraft which are at a reduced sound, right? So now this is to be designed at Mach 7 times the speed of sound. This is a speed which even a lot of fighter aircrafts, Air Force aircrafts don't have. So fighter aircrafts are small. If they go at very high speed, much more than the speed of sound, already the engineering has to be very, very special. But if such a huge big plane of maybe 300, 400 passengers has to be supersonic at 7 times the speed of sound, huge new engineering is to be there. What are the main problems? You see, first of all, it has to be designed in such a way that it goes through the sound barrier without crashing. So that is design. What are the other issues? If it is traveling very fast, what is the most important issue? Yes, you have guessed correctly. The friction with the Earth's atmosphere. If it is traveling at a higher speed, the friction will be much higher, and that means the heat generated will be huge. So the materials, any materials that current modern airplanes use, will burn up. So unless you have developed an ultra fine new material which is very light and still which is very, very high temperature resistant, you cannot make it. So again, we are giving an example which is a very good example of modern technology, but it is also a very good example of the use of materials. So now it may be metals that have very advanced style. It may be some steel and aluminum combination, but most probably there is a category of materials called composites. We will come to that chapter later on. So most probably it will be some very, very new type of composite materials. So new materials will have to be developed and engineered, and new techniques to manufacture the material, and new techniques that once the material is available, then how do we convert it into an aircraft and so on will have to be there. So again, this one example is about the use of modern material science and engineering, right? We are giving another example. You see, I am going very slow. I am going really very slow so that you really get excited in the beginning. So I'll again take a very short break. I need a sip of water, and then we will come back with you, inshallah.